All right, then let's start. A very good evening, everyone. Thank you so much for joining, and a very happy Diwali to those who are celebrating. Um, Today's session will be on PubMed search strategy. Search strategy, some people would feel this is completely related to perhaps a secondary data analysis or systematic reviews or meta-analysis, but search strategy, it forms a significant part of each and every kind of study design. So today we'll be covering on how would you do a literature review, how to get your keywords for your search string, what all databases there are, and we'll focus more on PubMed. So how we do the literature search in PubMed, making the search string and exportation of results. So why would you do a literature review? As I said, literature review is something that is required for each and every study design. If you remember, for those who were there in my last session, we covered protocol writing. And one of the important part of the introduction is the review of literature. So what does review of literature entail? It helps us to know what is already been published. It helps us to know if there is any new findings, or if there is basically a gap in research. So and you cannot formulate your research topic or understand if the topic is suiting your finer, that is feasibility criteria, if you do not actually do a literature search, because that will help you understand what all topics there are, whether it is being explored in your current population, and what the general consensus on that topic is. It will also help to aggregate these findings. Suppose multiple studies are agreeing on a certain correlation, or a certain cause and effect. So you'll understand that this is the general trend. It can also help you generate new framework or theories and identify topic or questions which require more investigation. For example, you perhaps could find a bunch of studies which are done on, say, cell line cultures, in animal studies, in tissue cultures, but have not been explored in human. So perhaps from this could be the basis of conducting a pilot study on a very small sample size of patients, in which you could introduce the intervention and see whether the effects are seen or not. So this is like the basic the steps that you would follow right from your review of literature to till the analysis part. So what the steps are: basically, first you'd get your question. That is, you'd follow. First, you'd see if the topic satisfies finer criteria. You'd see if the question follows PICO format. You'll determine your objectives as via the primary and the secondary objectives. Then you will search the entire literature. You'll see whether similar studies have been done or not. And then after that, if you're especially doing a review article, a systematic review, or meta-analysis, then you will see these studies, you'll screen them for a certain inclusion or exclusion criteria. Suppose you're including certain study designs, if you're including studies from published within the last 10 years. So that's one basis of doing a screening for inclusion. Then you'll assess the quality of these studies, you'll extract the data which is present from them, and then you'll analyze the data. So quality of these studies would be basically assessing if the studies are done properly or not. Properly in the sense, if their methodology is correct, if it's an RCT, if biasing was done correctly, if the proposed intervention or was correctly administered, if there were any dropouts, if outcomes measured were actually as per the protocol or not. Because there are many studies who would in their protocol mention that they'll be quantifying some set of outcomes, and while in the actual paper they would not do so, perhaps because some of the outcomes weren't favoring their hypothesis, or some outcomes they just it didn't go with the flow of the paper, so they wouldn't report it, and that significantly decreases the quality of the study. Extraction of data, especially if you're that this comes both for writing a protocol as well as doing a general review of literature. So extraction of data can follow a table in which you would include the first column always has to be the first author's last name, et al, and the year of publication. The second could be perhaps where the study was conducted, so in India or US, so people will know on what population the study was based on. Then you would perhaps come to the sample size of the population of the study. And then your next column would be the results. For example, quantifying the results in odds ratio or in risk ratios, hazard ratio. You could quantify the results. And at last, you could conclude, say, in this study, we found X was related to Y. So that would be the conclusion. And then you would analyze the data. You would check for some patterns which are occurring in these studies. If there is quantitative data, perhaps you could pool these studies together to conduct a meta-analysis, something like that. So first is the research question. And I think this has been consistently repeated over the past few sessions, that defining your research question is paramount. It has to be proper. It has to follow the specific PICO guidelines, and it has to be obviously feasible for conducting a research. So part of formulating a research question actually involves going through the literature. This is because you may formulate a research question, but as I said before, your feasibility may not be there. Maybe such kind of correlation, there's no, you're proposing a correlation, and there is no evidence whatsoever in the literature that there exists some kind of relation. So it'll be difficult to conduct such kind of research where you do not have any evidence that is supporting your hypothesis. So some things that you can consider while framing your research question is that what exactly you're trying to address through the question, what is already known about the topic, and is there any gap in literature that you can fill? If there are studies conducted maybe in the past 10 years which already show a correlation, there is no disagreement across any literature, there are guidelines published on it, and it's already a set and known fact. We would say, in other terms, the level of evidence is grade 1A. So we are not exactly covering level of evidence, but that basically means that it is the primary studies have been done, the RCTs, the cohort, case control, all kinds of primary studies have been done. All these studies have been collated together to form a meta-analysis, and the meta-analysis was strong enough, conducted across multiple RCTs. So the evidence is already fixed. It is 99% sure that this kind of correlation exists. So doing research, there's no gap in literature. And if there is no gap in literature, it is basically, it wouldn't be worthwhile exploring the topic for any reason. So having some form of conflicts in the literature is important, which can justify the reason for doing the study. And then based on your type of research, if it's a quantitative or qualitative or methodological, that is your, I'm sorry, if you're comparing different studies across different types of study design, or different methodology of answering a certain question, then that can be reviewed as well. So database search, it isn't as simple as one would feel. It's an iterative process, which basically means you'll have to do it again and again till you get a certain your desired results. So it basically involves 3 phases. That's exploratory, subject-oriented, and citation searching. So first, exploratory, that means your search would be as broad as possible to get all the form of evidence on a certain topic. And subject-oriented, you'd go deeper into your research question, and on the basis of the question that you have, you'll explore the database to find to find studies exactly on that subject. And then citation searching, that is, you'll go into the study in detail. You'll see the title abstract, you'll see the results of that study, if it actually matches your if it's similar to your research, or if the findings are agreeing to your findings or your hypothesis. So again, after, like, basically there are three steps here. One is you choose the database, you search with your keywords, and you revise the database with terms. Suppose you feel you could add another keyword to make your search results more comprehensive, then you could perhaps do it at the third stage. So list of databases. um, so first, ba- um, uh, specific to OBGYN, we have two databases here, that's LactMed and MEDIRS. So LactMed is basically more on lactation studies. So it's on peripartum period, postnatal period. That database focuses on those kind of studies. Whereas MEDIRS, it basically is on midwifery and nursing. Other databases, which are basically standard databases that one can use, are PubMed, Sinol, Embase, Cochrane Library, Google Scholar, and Biomed Central. For us, I think PubMed is obviously free, and Google Scholar is free as well. For the other databases, some colleges do offer some kind of subscription to these databases. If you don't have it, it's still all right. You could do your search in PubMed and Google Scholar. Google Scholar is already very comprehensive. So making your search string. So for each key concept that I'll show you with examples later. With those key concepts, you'll make a set of synonyms for each concept, and from that you'll be joining them with certain operators and forming your search string. Now, search string is not only limited to the keywords and the joining of those keywords. You can also add certain limiting factors to your search string, that is perhaps publication date after 2010 or within the last 10 years, so 2014 to 2024. And a publication type can also be used. For example, you want only cohort studies. If you want only trials which have been conducted on this, then you could add that keyword as well at the end of your search string. Or there are specific methods of adding these kind of keywords at the end of your search string in PubMed, which I'll be showing you later. So ideally, when you're doing a review of literature, comprehensive review of literature, you should try not to limit your studies to a specific methodology of conducting, or even a specific study design in some instances, because there is no reason for you to seek only case control studies for doing a review of literature, especially if you're writing a protocol or if you're doing a review. For in some instances, you could perhaps seek only for case reports if the evidence is, if there are no case control studies, if there are no cohort studies, and it's just an emerging finding that people are seeing from multiple that is being reported from multiple hospitals, but there isn't any any large scale research on it. Now that you could perhaps seek for case reports, but focusing on the methodology and doing your and making your search string isn't really useful or advisable to do. So after that, you would select the studies which in accordance to your inclusion or exclusion criteria, or which match to your research question. So these are some of the Boolean operators. This is what we call them. So when you're trying to join two keywords together, you'll be using Boolean operators, which are a set of keywords which can help you join strings in a manner that you would want your results to form. which basically makes sense. So when you use and, you want both the terms to be present in your in whatever articles you're getting. You want both the terms to be present. When you use or, you want either this or that. So or is basically used for synonyms. For example, if we're focusing on hormonal replacement therapy, all studies may not use the term hormonal replacement therapy. Some of them um, could have suppose micronized estrogen, or estrogen combination pills. So when you try to make a search string, you'll have to include all of these synonyms together, and you can join them with or, so that even if a study, say the authors did not consider using HRT, they would have used that other term, and you can find those articles. And not would be when you're trying to completely restrict a certain set of keywords. So for example, you're trying to seek for only human studies, and and you do not want animal studies. So you, whatever search string you make at the end, you can put not, and then you could mention suppose not, and then in the brackets you could be mouse or animal or mice or rat, end bracket. So it will remove all those studies which have that specific keyword in them. But actually, when you use not, it's just like an advice that I've been given from professors, that it should be used very carefully. Because when you just put keywords together, and suppose, like, think about if you're writing a research article yourself, you may use the word animal or mouse somewhere or the other in your study. Perhaps you're just stating that animal studies have been done on this previously and they found something. So you have used the word animal there. And when you're putting it in not, you're basically removing all those. And this might remove some articles incorrectly, something significant which you might consider, but it's been removed because of the not string. So try not to use not. And if it's like completely a compulsion because you're getting um, a lot of studies, then perhaps you could restrict the term to only title. So you could select studies which do not have animal or mouse in their title. And I'll show you how to do that in the demo. Okay, so this is one way of joining the keywords together across different databases, but it's mostly similar across these databases that I've mentioned here. So suppose we're doing body dysmorphic disorder. So you can include the yeah, so you can include the shorter version of the term or the abbreviation. You could include one synonym as in body dysmorphia, another as in body dysmorphic disorder or dysmorphophobia, and then this would be the end of your keyword, which basically works on BDD. And then you could join with and suppose you want to check with if you want to evaluate gender by differences, then and then your second term could be gender or sex or male or female, and then your third term, since you're checking for differences, can be differences or changes or variation. So we'll be making a search string together after this. Till now, does anyone have any doubts? Feel free to unmute or just put a message in the chat box. All right, I think we can continue. So we'll be making this search string. Uh, yeah, perfect. Thank you. So we'll be making this search string on this question right now together. So this is, what is the incidence of lung cancer in non-smoking women on prescription of HRT? So can any one of you just unmute yourselves or put it in the chat box? How would you identify what is the PICO in this question? Okay, so basically the PICO here would be non-smoking women. That's the population. The intervention here would be prescription of HRT, hormonal replacement therapy. The There wouldn't be any comparator here in this question. Your outcome would be the incidence of lung cancer, and time period isn't specified here. So let me just go to the previous slide here. Here, there are some key terms we can identify. One is lung cancer, and the second is HRT. So I can form a search strategy which will help me get all the studies which report lung cancer among HRT taking women. So these are my broad keywords. That's lung cancer and HRT. Zainab, can you put the poll? So basically, the question that I specified again, that's lung cancer, yeah, incidence of lung cancer among non-smoking women under HRT. So what study design do you think this can fit into, considering finer uh, guidelines?
Um, Case control would be the best, I think.
Case control. What would your cases be here, and what would your controls be?
Uh,
Okay, so it'll be
we look for
basically women.
people with
Yeah.
women with lung cancer, women without lung cancer, and then we look back for exposure to HRT.
Yes, that would make sense. That can be done. So I think this is basically a multiple choice.
Yeah.
We can do a cohort. We can do a case control. RCT, no, we cannot do an RCT here. I'll just explain why. Because you cannot introduce any intervention that you know will cause some kind of harm in any patients. We cannot introduce HRT, like, take two groups of people, one who in whom we are introducing HRT and one who were not giving HRT, and then follow up if they develop lung cancer. It's just ethically incorrect. So RCT will not be possible. Yes, as Olivia mentioned, I hope I'm pronouncing your name correctly. Case control can be done, and cohort would be one of the best. I'm sorry, cohort could be one of the best. I'm sorry, a cohort can be one of the best study designs, because here we can select women with lung cancer, and we just check if they had taken HRT before or not. So thank you for that. Let's proceed. Okay, so now we focus on the two keywords that I mentioned of the research question here. One is lung cancer and one is HRT. So what we would do here is first try and identify different synonyms of the term lung cancer. So one could be non-small cell lung cancer. Then there's bronchogenic carcinoma, small cell carcinoma, squamous carcinoma, lung malignancies, SCLC. And I think one question which everyone would have here is how would I know what are the keywords of a certain term, or how would you select these kind of keywords? One thing would be doing a review of literature for the review of literature. That is, you check what the studies, if they've used different kind of terms, but that's not efficient. Another method is using mesh terms. So I think I could demonstrate that to you. One sec. So this is um, like a very convenient system given to us by PubMed, which can help us identify all related terms to a specific keyword we're looking for. So suppose, let's say we're searching for bronchogenic carcinoma, for example. So this is kind of different entry terms in PubMed, which is related to this topic. So um, I'm sure none of you would have thought bronchogenic carcinoma could be expressed as bronchial carcinoma. When you would type bronchogenic carcinoma, you wouldn't get studies which are mentioned bronchial carcinoma, and it's basically the same thing. So that's one way of doing it. Another way is, suppose we have lung neoplasms here, lung cancer. So these are different ways of writing the same thing, that is lung cancer. Could be pulmonary cancer, it can be lung neoplasia or neoplasm. And here you could see the different the subheadings which come under lung neoplasms, like bronchogenic carcinoma, non-small cell, small cell, mesothelioma. So basically, depending, you could include all of these terms to make your search strategy more to make it more comprehensive. Okay, so back to our PPT. So these are some of the terms I selected for lung cancer, that is non-small cell. And I could obviously expand each of these terms here. So NSCLC would be one term, and another term would be non-small cell lung carcinoma, like all expanded. And SCLC is one term, then small cell lung carcinoma can be another term. So that's done for lung cancer. Then we go to HRT. HRT, you would obviously mention the word HRT itself. Then you would mention hormone replacement therapy. Then you can mention all of these keywords here: estrogen replacement, ethinyl estradiol, progesterone replacement, estrogen replacement with an O there, because that also that also will carry a lot of significance, because these are just computer based systems. They don't know what you're looking for. Whatever keyword you will give them, they'll just retrieve those results and send it back to you. So you want to be like, teach the computer what you want. So teach them that you want estrogen and estrogen with an O as well, and synthetic estrogens, and all these kind of combinations could be included in your search string. So how will you form the final search string now? So you have the different keywords of lung cancer. You have the different, synonyms. You have the different synonyms of HRT. As I said, synonyms should be joined with or, because a study may use lung cancer, a study may have written bronchogenic carcinoma instead of writing lung cancer. So you want to combine all those studies together. You want all those results to be there with you. So you use the Boolean operator or, and you join all those keywords. Now, ideally, if you can see here, I've put it under the double quotes. So when you use double quotes in PubMed, it exactly gives you, for example, lung cancer. So if you put double quotes, it'll search for lung cancer, like both those terms separated by a space. It'll exactly search that. But if I do not put quotes here, then it'll be a bracket lung and cancer. So it'll search for those studies which will have the word lung and have the word cancer, not necessarily mentioned together as lung cancer. I hope you understood this. If anyone has any doubt, please ask. Yeah, perfect. So I'll just repeat this again. When we're using double quotes, we want to search the exact string which is mentioned in the double quotes. If we're not using double quotes, then it just searches studies which have those two terms together, those two terms not necessarily together used, after one space. Yeah, so we got our synonyms for lung cancer ready. We have our synonyms for HRT ready. And finally, we join both of them together using the operator and. And then we get all the results which have all those synonyms of lung cancer and like any one of those synonyms of lung cancer and any one of the synonyms of HRT. So you must have seen I referred to mesh terms. So what exactly these are? Um, stands for medical subheadings, and these are words which help you retrieve articles which have that certain keyword as their main topic. For instance, suppose you're doing a research, suppose that is your research question, that is lung cancer and HRT, and you've already written the paper, you're publishing it, and somehow in your discussion part if you've mentioned that such findings are also seen in endometrial cancer, or such findings are also seen in breast cancer, and you've just mentioned that, but that isn't your main topic, but you've written it in discussion. And then someone else tries to search for articles on lung cancer and HRT. They want to find out the research here and find out any gap. And when they search, or suppose they're doing some other study, suppose they're doing some other study on colorectal cancer. They search and they get your study, but do they actually need your study? They are doing it. They are doing a different study on colorectal cancer. Their research question is different and your research question is different. You're focusing on lung cancer. So just because that keyword was mentioned in your study, um, results are basically getting incorrectly retrieved. So mesh terms, they help you. This is done by PubMed automatically. That is, it automatically assigns certain main headings of each and every study, what the study exactly focuses on. And when you're doing a review of literature, it will help you identify these specific studies. So using mesh terms gives you precise and a very comprehensive search result in which you can be almost sure that most of the studies, if not all, will be somehow relevant to you according to your research question. So this is basically there in the NLM database, mesh database. And here you will, as I showed before, you will search for a specific keyword. You will you can see since when is that keyword indexed in PubMed. That is, when was the first research on this topic done. You can see what are the subheadings of that specific keyword, like I showed for lung cancer, that is bronchogenic cancer, non-small cell lung cancer, something like that. And then you could select a combination of these studies to make your search string. And finally would be exportation of results. So so I think I'll just show this to you in the demo. Just so that you know, exportation of results can be done in different formats. You could export them to CSV. You can export them as TXT files, and you can export them as .ris. If you're if you're doing a systematic review or meta-analysis, then exporting studies in a way that will help you import them into other reference managers like Mendeley, as I mentioned the last session. For that, .ris works fine. That's like speaking from studies that have been a part of. But TXT works, but it isn't much. What do you call? It isn't compatible to all forms of reference managers. .ris works the best. So let me just go into the practical demonstration. I think people will have a better idea. Till now, does anyone have any doubts? Yes, Deepika, Dr. Deepika.
No, Doctor, can you please repeat RIS format once again?
Okay, so there are different ways of exporting results. Um, there is TXT, there's CSV, and there's .ris. Um, so when you're trying to finally export these results into your review manager, or your Mendeley, Zotero, or EndNote, um, or you're doing a systematic review, you want to export it to Ryan, .ris works the best because it's kind of widely accepted. So try your best to export results in .ris. If not, for example, in PubMed, you could export it in PubMed format. There's like not TXT but PubMed format, and that is acceptable by, I think, almost all forms of all the exportation softwares. Does that answer your question?
Yes, thank you.
Perfect. Okay, so this is your PubMed site. When you start doing your search, it's better that you can go to the advanced tab here, because it will give you much options here to select different ways of doing your of formatting your term. So let's just go with the example I said before. There is lung cancer in HRT. So I just enter lung cancer here, for example. So here you can see what kind of like where exactly do you want that keyword to be in. So when you mention all fields, you're kind of saying anywhere in the study, anywhere that is in the title, in the abstract, in the paper itself, in the manuscript, in the intro or discussion. If you have that specific keyword, then give me those results. So all fields stands for that. Then there is author as well. So in case you're trying to find out a specific author's any author's results. Suppose they're working in a specific field and they're pretty famous, and you want to see what kind of research they've done, then you could just put their name here and mention author. So it will just search in the author place. Then there is book that will only go through books which have been published in this topic. Um, then there's conflict of interest statement. Now this isn't much used. What is important to us is mesh terms here, because this will only go through those studies which have lung cancer indexed as their mesh term. So that was the main heading of that study. And then another important one which is frequently used is title abstract. So as I mentioned before, on screening, suppose you want to remove animal studies, then you want to remove all those studies which have mouse written in them in their title or abstract. And that kind of makes sense because people might mention animals or mice in their whole manuscript. But since that's not their entire focus of research, they wouldn't actually mention it in their title or abstract. So that would be one method of getting your results. So let me just show you the scope of these findings. So suppose you're doing all fields here, then you'll add the term and you search, for example. So you can see there are like over 4.5 lakh results here. Yeah. But if you put the same term and search it as mesh term, then you get 2,89,000. That means out of those 4 lakh results, only 2 lakh of them are actually have something related to lung cancer. Like lung cancer is a broad heading. Now this is not the way of doing a search string, obviously, but I just want to emphasize on the fact that how different these two terms are, all fields and mesh terms. Mesh is completely specific, like the main heading, and all fields is anything. Lung cancer could be mentioned anywhere in the manuscript, but the manuscript may not have any relation with the topic as such. And then there's title abstract. So this will again give you the results in which lung cancer itself is used as a title or an abstract. So this you can see again, these results are much less than mesh terms, because what mesh does for you is that, as I showed you in the mesh database earlier, which I'll be showing again as well, it searches for that word and searches for the variations of that word, like lung neoplasia or uh, or cancer of lung. So it combines all of those terms and gives you the result. So it's the most accurate. But title abstract, it again searches only for the term lung cancer in the title or the abstract. So that's one way of doing it. So suppose we have here, as I mentioned before, lung cancer without the double quotes will give you all the results, and lung cancer with double quotes will give you exactly lung space cancer. So let's just restrict to mesh, I think, yeah. So you've added your first keyword here. Now I want to add the other synonyms that I had found earlier. So here you could just select add with and or not. So I selected or, and then say bronchogenic. Again in mesh. So when I put or, it combines both of them. We can perhaps put just one more keyword for demonstration. Okay, so that's done. Then then our second keyword there was HRT, hormone replacement therapy. So yeah, okay. So for hormone replacement therapy, I want to add it with an and here I mention hormone, and it adds that keyword for me. And let's say HRT. Okay, so now is a very important step. You see, I've just blindly added the terms that I made as per my search strategy, and I'll just search them up. Okay, so it gives me 23 results. So what the problem is here is that once you make your search strategy, one of the most important steps that people frequently miss is seeing the details of your search strategy. That is, you gave some term. How has PubMed itself uh, like understood the search term? Like, how does it search your results? So here you can see, yeah, so it gives me bronchogenic carcinoma and HRT. So these were our major results here. Suppose the same thing can be so what I want to say here is that brackets matter a lot. Okay, so when you're doing the same thing here and you just close the brackets here, you're getting 12,000 results because the search string here is basically incorrect. What it's doing is that it's giving lung cancer or bronchogenic carcinoma or small cell carcinoma and HRT, and this is just one term. And this one term is being combined with or HRT. So it's giving all results which either have the word HRT or this huge string here. So you're not getting your desired outcome, which is, what was your desired outcome? It was lung cancer and HRT. I want all studies with lung cancer and HRT. And this string here isn't just correct because it's searching for terms which either have this or this whole thing here. So that's incorrect. So one thing that one should always keep in mind when you're doing searches like this is check your brackets, because like one bracket makes a lot of difference. So once you have your search string here, you could just modify it here to like remove the unnecessary brackets here. And there we go. We have the corrected result, because what we did is we put an entire bracket on lung cancer terms, and then with an and, we put an entire bracket on the HRT terms here. So that's the demo on PubMed. And then how you would export your results. For example, we have the same thing here. And we want to export all of these results. So if we want to export everything, then there's just save, then all results. And your format should be for PubMed, like based on personal experience, PubMed works the best. But if you want other formats, say you're wanting to do your further review of literature in Excel sheet, then you could perhaps download it in CSV as well. Now, PubMed doesn't have .ris, but all the other databases like Embase, Scopus, Cochrane, Web of Science, all of them have .ris format. So ideally, apart from PubMed, all the other databases should be exported in .ris format. And then suppose other terms that I mentioned for limiting your search, suppose you want it only in the last 10 years, and you could directly select it here. In the last 10 years, you want all research, and you can find that. Then suppose you want yeah, suppose you want to find only clinical trials being done on this topic. So these are only clinical trials. Now, ideally, you should not be using this, because there may be some studies which are clinical trials, but which haven't been exactly specified by the PubMed database to be a clinical trial. And this is like especially true for very old studies, or studies which are published only as an abstract view. So it's better you not use article type filter, but you can, like, it's there, but it should ideally you should not be using it. So that's that on PubMed. So I'll be showing you mesh again. Till now, does anyone have any doubts with PubMed? Yeah, I think it's all right. I'll just show mesh again then. Okay, so when you start mesh, you just search mesh database and mesh database, and you'll get this page. So whatever terms, let's just say, suppose hormone replacement therapy. So these are like the different ways of combining the same things, because if you specifically write hormone replacement therapy in quotes, then you would get the exact term. But some studies may have used it in a different way, like a replacement therapy with hormones was done, for example. So that could be one way of writing it. So you could perhaps make your string using this term as well. And then you can find here a subheading estrogen replacement therapy, which PubMed indexes under hormone replacement therapy. And here you'll get the comprehensive list of all of the kind of combinations. You find postmenopausal HRT, you find estrogen replacement therapy, then there's just estrogen replacement, and then you could search for progesterone replacement as well. Okay. So I think that's it for today. I've shown you how to work with Mesh. I've shown you how to work with PubMed. Um, I think, yeah, that's it. If anyone has any doubts, any questions, please feel free to ask. Okay, so I think there are no questions. All right, then we can wrap up this session early today. Can people please switch on their cameras? All right, then thank you so much for joining today. We have our post-event questionnaire. I think Zainab has put it in the chat box. So please make sure to fill it out because your certificates and your score would be the basis of the certificates. And thank you so much for joining. If you have any doubts, then please feel free to post it in the group as well, or you could email us. Thank you so much. Enjoy your Diwali. Bye, guys.